was no flying saucer.
Running here the previous version that I had at the 2.8 volts, and this will kick around 2 point some volts. It won't go as low as the 1 point something before of the other model. And this is already kicking over 1 amp and only producing 0.30 1.2. It's going 7,000. 7,800 RPMs. And this will never reach the max. I believe Lightworker took it to the max and it was like 25,000. 11.8. That's at 5.8 though. 12.2. 20, 23. But it's pulling out 2 amps. That's max. 31. It's gonna burn. About half amps. Maybe it has to be tiny better, but you know, the torque is good. But it's just comparing that the big difference between the North stators, the all North stators on this. Alright, so here, this is the a 5-pole all North that I have displayed on the forum. We have the little motor right here. It's I have it hooked up there with, and what I'm doing is I have the PSU set at current max limit, and I'll be regulating the voltage, and just wanted you to see it, the smoothness of when I start turning this at low voltage. And I know it's high amperage, but remember that this is 1.3 ohms at each pair, so it's supposed to be, but the other asymmetric is higher than that. Right here it's going 1.5 volts. It's producing out there half a volt, 0.46. So it's 1.45 volts. I'll go at 3 volts. Getting out like taking 0.82 amps and about 2 amps. Now it's going here at 67, 6,800 RPMs. Gonna go higher. Still remains about 82, and now it's going 11,000. $11,340, $350, and 0.76. It's producing 2.9, 3 volts out of 4.2 volts. When I increase it now to 5.8, still at 0.84, and now it's going at 16.8. Alright, and it's producing about 4.4 volts. I will keep increasing. Still below 1 amp. And now it's going 22,000 RPMs, producing about 6 volts. $22,900, 492. I'm gonna go higher. Now it's 1.2. Now it's going 26,000. $29,600, and it's at 9.6 volts. Gonna go higher. 12.5. Going 35,000. 1.3 amps. I'm gonna go higher. 44,000. 43.8. It's gonna melt down. Yeah. Too much for the casing. Something came loose in there. But it keeps going. Maybe a winding just came loose. But no, I don't think so. The little rubber I had here, just unhook the power off. Yeah, it was a rubber that I put in here so it won't move. It's right here. Just came loose. But and of course the bearings, which is not even bearings, these little motors have bushings. They're kind of hot going that speed. So, but it still works fine. Whoops. Yeah, it came out. $39,000, 40,000. It could come apart at this speed. It's not designed to go that speed. It's about twice what it's rated for, which is about 20,000. So on the original casing, but still holding. And this is the type of winding that it's gonna look something like this. This is another one I did with higher resistance, so it goes lower ampere. And I had to put these little things, these little hedges, because wires will fly out. It's not designed for this. This is supposed to be a little epoxy bowl here, so it can stand the speed and the friction will be less. But this is what basically it will look like once you get the all north type overlapping coils. And I had to close the gaps, and as you can see, it's in the position that you can see it's not burnt or anything. It's there. I also have the little hedges in there, otherwise it would have blown off. But these bushings are mounted on plastic. Anyways, the point is that the brushes are set right here, across from stator gap, about 90 degrees of stator gap, which is guided by this little indentation where it holds the inner walls of the magnet. So see right there the brushes and the gap right here. So it's 90 degrees, just as stated in the graphic. maybe a little bit. P1 right here, it'll be at the end of the fire stage, so it'll get the bisector will get this closer over here, but maybe 15-degree angle or so. So, but we can move the brushes a little bit and adjust it. Perfect. In my case, I put them around the end, the edge of the gap right there. Alright, so this is the same type, the Old North, and what I have done here, I have set the rear jumper on the, let me show you here. I've set a rear jumper on the back part, and I'm fitting the same way positive, but I'll be fitting negative on the front here, and I'll be taking power from this negative, which goes to the source, and the other one from the rear jumper power. And here are the two cables. So I'm going to be lighting up this bulb, and getting it on. When I get it on, this is a automotive bulb, 12 volts. I'm gonna get it to around 9 volts. That's fine. And I'm gonna hook it up. And you see how the motor increases only by like 30, 60 milliamps. And the motor speed, let me take a readout at this speed. That's 15,000 RPMs. $15,480. So when I get the bulb, and while it is lighting up, $15,700. So watch it now. 15.4. So actually it went up. Get this cable out of the way. $15.8. Disconnecting it. Kind of hot. It went down to 15.6. So it actually increased, and the updraw is 0.35. It goes up, of course, when you, but only for 15.5. Put the bulb on. $15.8. Take the bulb off. 15.3. Put the bulb right here. Oops. Bye, bulb. So I can go higher. Still at 38.38. And it's going 15.9. 16. 17.8 with the bulb on. 18. Take the bulb off. 17.9. On. 18,000. I don't want to take it too high because it's going to come apart. $21,000. Bulb off, 20,000. So it increased about 1,000 RPM. 21.4. $20,008. So it increases under electrical load with this type of connection. And this is an incandescent bulb, like about 3 watts or so. So the next test would be to put the meter in here. So it's giving out 0.94 amps over there. It's got 0.85. Go higher. 1 amp in here. And 0.95 over there. And this is set for DC amps. 0.93 over there. And yeah, the 13.6. Now there's no 0.1. I close the bulb. And it's 1.1. 1.03, 99 over there, 98. And we got power here, we got mechanical torque in there. I made a short circuit. So .99, 1 amp. Take it off. So you see, it's not the clamp that is hooked up to magnetic fields or nothing like that. So it's 0.1 or nothing. So 0.34 at the power source. Close the gap. 1.1 amp versus 0.93. And we got a both bleed. And pretty good torque. And it's only a 9.6 volt. The bulb is not fully lit though. What I'm trying to show is not over unity, but it's showing that it renders back the same amperage, 1.4, changing the same as the source. And we have the light bulb lit up.